Welcome everyone to Unit Masters Week 3. And this week, out of our 6 weeks program, we're speaking about consensus mechanisms. On Tuesday, you already heard how Vlad is thinking about governance in Web3 and beyond Web3. And today we have Kevin here, Kevin from Moonbeam, who's sharing with us a more technical perspective on proof of stake and consensus in general, and then how at Moonbeam, for example, they apply these principles. Welcome to Kevin. I'm reading out your bio. Kevin is a developer relations engineer at Moonbeam, where he helps teams deploy to Moonbeam and strengthens the community through technical education and developer-focused events. Kevin has extensive knowledge of EVM-based blockchains and was an early member of the Cornell IC3 initiative for cryptocurrencies and contracts. And previously, Kevin worked as a software engineer for JP Morgan and represented Quorum as an ambassador. Kevin graduated from Dartmouth College with a degree in computer science and economics. And I feel very blessed to have you with us, Kevin. I'm very interested and curious also to hear how you relay 5 consensus mechanisms to our audience here of students from across the globe. Welcome everyone, and the stage is all yours, Kevin.
Thank you so much for the warm welcome, and thank you so much for the invite. I'm thrilled to be able to chat with you today, and I hope you have some questions at the end. That's what I'm here for, yeah, I'm very excited. So thank you so much. You heard a little bit about my background. I used to be in the Web 2 space, but I jumped to Moonbeam about a year ago. So I highly recommend that as you're getting into Web 3 and you're saying, how can I get more involved, right? Think about getting a job in this space. It's a lot of fun. It's a lot of work, but it's something where when you do what you love, it's a ton of fun. So today we're going to talk about consensus and incentive alignment in proof of stake systems. And the biggest question really when we're thinking about organizing blockchain nodes, right? Blockchain nodes are just going to be listening to transactions. They're going to be collecting them, and they're going to be ordering them so that we're all kind of like in agreement as to like what actually happened on the blockchain. And why are we doing that? We're doing that because it's not just one computer that's running the blockchain, right? It'd be very easy to just have a single big server just running the entire blockchain. And then that single server would say what happened and what is like the true history on the blockchain. But that's not decentralized. That's not what we're interested in. We're interested in getting a group of people or a group of computers to come to a decision about a shared history of the blockchain. And so when we're trying to figure out, okay, who can actually run a blockchain validator node in the general sense, our 2 biggest questions are who can participate, and then what happens if they lie? So assume that there's one correct history, right? If Alice paid Bob and you're a blockchain validator and you tried to say, no, actually that transaction didn't happen, or you tried to say, well, it happened, but it was actually only half the amount that you thought it was. These are serious problems, and there has to be a way to keep these participants accountable. And we can take steps to fix this if these participants are acting in a malicious manner. So thinking about those 2 questions, right? I have an example of Bob. He wants to build a new blockchain, and he says it's going to be the most decentralized blockchain that's ever been made. Assume it scales to an unlimited number of users. And Bob is he's a little bit naive, right? So he's not really sure. But what he does have is that he knows that he can scale to as many people as want to join as possible. So Bob says, okay, all you need to do is send me your email, and that's all I need. And then we'll sign you up to be a validator. I'll send you the link, and then you can run a node. And each block, we're going to randomly pick somebody to be the block author, and that will be that. Does anybody recognize any problems with this approach? You can, I guess you're all muted, so sorry. But if you could put it in the chat too, if you recognize any problems. Yeah, go ahead. I don't know if I can, yeah, you can unmute yourself, I think, Nadia.
Hey, well, if you randomly pick someone, how can you make sure that that is not a malicious act?
data. And yeah, and you also need to ensure that there's always someone to pick, right? So you need to ensure some sort of of validators.
Certainly, good point. Yeah, we can't. That's a huge problem. We don't know if they're going to be malicious or not. And in this simple design of Bob's blockchain, there's nothing that says that this person can't be malicious, and they have nothing to lose, right? They don't have anything at stake, basically. So that's certainly one problem. That's a great problem. And there's one more which I want to highlight, and that's that anybody could just create 100 emails or 1,000 emails. We have no idea who actually, the link between a person's identity and how many nodes they're running is not known. So one person could be maliciously saying, I want to go ahead and just run, thousands of these nodes. And then the problem with that is that the control of the network is going to be possibly in the hands of one person. And that's an extremely dangerous problem. Essentially compromises the entire blockchain. So moving along, when we think about consensus models, right? The idea of like assembling transactions and packaging them into blocks, we can kind of think of that as like a solved problem. So consensus models are less about organizing transactions, and they're more about Sybil resistance. And a Sybil attack is kind of what we just described in the last example. It's when you have a single person who's masquerading to be many different people. So you're a single person and you're trying to run hundreds or thousands of nodes. And if the blockchain is 500 nodes and you're running let's say you're running 500 of them, right? That's a serious problem, right? And so maybe there's one thing you could do. Maybe you could say, well, if you want to run a node, you have to submit a passport, right? I need to see a scan of your passport. And that's one way you could do it, but it's not a foolproof system, right? That person could just go to their friends and they could say, hey, give me your passport. I'm going to create like a couple more nodes. And so there's many different factors that you need to think through. But consensus models are, importantly, they're about preventing people from pretending to be more than they are and getting kind of like an undue share of resources and an undue share of control on the network. So when we look at blockchain consensus models today, there are more than these, but these are the kind of big ones that are in use and have been in use for a couple of years. So let's go through them one at a time. So the first one is proof of authority. If I'm a benevolent dictator and I'm creating a new blockchain, I can just pick my validators and I can say, okay, I'm going to have you, and I can specify the exact requirements that they need to have, whether they need to have a supercomputer or a regular MacBook is just fine. But I could also set some other weird requirements. I could say, hey, there's a membership fee, and you actually need to pay me to be part of this proof of authority consortium. So this proof of authority model may be used by banks. It may be used by trade organizations. It may be used by groups of people that are trying to dip their toe into blockchain, but having a public and open blockchain is a little bit scary. So instead, we're just going to do this proof of authority thing, which is just a couple of different known entities. Now, this is not decentralized, so this is very problematic. But the benefit of a proof of authority system is that you know exactly who your validators are, and if they misbehave, you can easily replace them. So if anybody submits a fraudulent transaction, it's very easy to recognize them. You know who they are, and you could say, hey, you're out. Moving along to proof of work, this is the one you probably heard the most about. Bitcoin has a proof of work consensus model, and the way that this works is that it's open. In theory, anybody can participate. And when the Bitcoin blockchain first launched in 2009, you could open up your laptop and you could actually mine Bitcoin and earn rewards just from your laptop. But in practice, right, only professional operators with huge warehouses of computers like the one in this picture are competitive in terms of actually earning rewards. And here, I see some good questions. This is awesome. So I'm going to keep this on the side. So proof of work, the issue with proof of work, though, is that the more energy that gets expended does not actually translate to a better experience for the Bitcoin blockchain. So Bitcoin can run just fine with 10 nodes or 100 or 1,000 in terms of the difficulty, right? So as more people jump into this proof of work system, it does not result in like better outcomes for the system. The transactions are not faster or anything like that. All it is expending more energy. And to kind of explain that a little bit more, right? We can think of the bundling of transactions into blocks. We can think of that as a little bit different from the proof of work puzzle that's being solved. So Bitcoin miners are collecting these transactions, and that's a trivial task. That takes like no power. You're just listening for transactions, put them into a block. But at the same time, they have to solve this very complicated puzzle, which requires a huge amount of resources. And like I said, it does not benefit the blockchain in terms of improving it. So that brings us along to proof of stake, which is what we're most excited about. And kind of, this seems like the most promising option, and it has one major advantage over proof of work, which I'll discuss in just a second. So the way proof of stake works is that anybody can lock up the required stake and participate. It may be a little bit easier to acquire this stake than to acquire specialized computers. You don't have to have connections and have all this fancy equipment. You just need to get the appropriate stake. And a lot of times you may have heard the term like a 51% attack. That's kind of like a general term used for if an attacker is trying to take control of the network, they want to get more than 51% of the network, and then they can mess with it. So if you're on a proof of work blockchain, right, you take your specialized computers and you point them at a blockchain. You can attack that blockchain with your computers, and regardless of whether the attack succeeds or fails, you still get to keep your computers. So you can attack one blockchain on Monday. Tuesday, you can turn around and try to attack a different one. Wednesday, another one, and so on and so forth. With proof of stake, that's not possible because of two reasons. If you misbehave, you could actually lose your stake. You could get slashed, and you could lose your entire up to your entire stake. Now, if it's a more you're not misbehaving, but you just configured your node the wrong way, or you forgot to start up your computer, then you might just miss out on rewards. So proof of stake, as we mentioned, has a significant bond requirement generally. That prevents Sybil attacks, right? You can spool up a couple different nodes, but you're going to need to have the appropriate amount of stake for each one. And that's difficult to acquire. And proof of stake, it's important to know, is energy efficient. So regardless kind of the number of nodes you have, you can scale from 100, 1,000, 10,000. It's not using like 10,000 times more energy, really. It's because when you're running these proof of stake nodes, they use the energy of like a simple computer, just like a light bulb, really. So it's like the equivalent of turning on a light bulb. These proof of stake nodes are doing networking and communication. They're basically just listening for transactions. They're packaging it into blocks, but they're not doing any of this complex puzzle computation that's so energy intensive from the Bitcoin blockchain. So looking at ETH2 staking, if you wanted to run your own validator, that comes with a significant bond requirement. So to run your own validator for Ethereum or ETH2, you need 32 ETH. At today's prices, I think that's about $100,000. So this is an extremely high bar. But many exchanges offer pooled staking. So they may have either low minimums or no minimums. You can stake with Binance or Kraken, and you can get most of the rewards, maybe minus a small fee. And if you prefer, there are decentralized options available, which is awesome. So this is just the breakdown of kind of the different options for ETH2 staking. Let's take a look at Moonbeam's approach. So as an introduction, Moonbeam is an Ethereum-compatible smart contract platform on Polkadot. It allows you to deploy your Ethereum dApps, so all of your Solidity-based apps with no changes, and you can gain access to the entire Polkadot ecosystem. So we believe that the future is multi-chain, and that dApps, right, they're going to be deploying to perhaps Ethereum, perhaps Polygon, but they're also going to gain access to the Polkadot ecosystem, which is extremely powerful for a number of reasons. And we're going to be, we are the easiest way for teams to deploy to Polkadot because of our seamless Ethereum compatibility. And just to give a brief introduction to Polkadot, right? Polkadot is a layer 0 blockchain. So you can't deploy any contracts to Polkadot itself, but Polkadot holds several different blockchains, that run on top of it, including Moonbeam. And the benefit is that they can all connect and talk to each other, and in a way that's much more secure than, for example, bridging between different networks. They can talk to each other. And the idea is that we'll have an ecosystem that's greater than just the sum of the parts. And these layer 1 blockchains will do many different things. Some will specialize in decentralized identity or privacy, or they might specialize in storage. And so by being part of this ecosystem, you're able to access all of these different parts, which is really cool. And Polkadot's idea is that there's not going to be a single blockchain where we just try to put through as many transactions as possible, where it's kind of this one size fits all blockchain, but instead there's going to be many different ideal blockchains. And in terms of our proof of stake model, Moonbeam uses a proof of stake based model, so we don't melt the polar ice caps. We're a very efficient chain. We have currently 64 block producing collators, and this is going to increase in the medium term to probably about 100. And they're required to put up a significant bond amount, and they're selected to produce blocks pseudo-randomly. But we have an on-chain way for folks who don't have this huge amount of stake to participate and earn staking rewards. And we call that delegation. So anybody meeting a modest minimum, I believe the dollar conversion is something around $300 or so, they can choose a collator to delegate to. So they can pick a specific collator. They can say, hey, I want to jump on board, and they'll earn a proportionate share of rewards for what they contribute minus a small collator fee. And the idea of Moonbeam's staking architecture is to align the interests of collators and delegators. So delegators have the exact same interests as collators. Collators want to be online, producing blocks, behaving well and in a high performance way. And so delegators are looking for the same thing. And I have a picture here of the Nimbus 2000 broomstick. This is because our parachain consensus is that we use for block production is called Nimbus. And so yeah, we just have that there. So I can take questions, and I see that there's lots of questions here in the chat, which is amazing. So would the best way to go through kind of the questions in the chat, kind of like starting from the top?
Yeah, let's do that. Yeah.
Awesome.
But maybe also before we kick off with the very technical questions, maybe a big picture overview on why did you guys choose to bridge between Ethereum and Polkadot? What's the difference between these two networks? So we can all get on the same level of knowledge before we then go into deeper technical questions.
Oh, for sure. So Polkadot is solving a lot of issues facing blockchains. One is governance. Polkadot provides on-chain governance, but essentially, Polkadot provides a way for blockchains to talk to each other, right? That's secure and scalable. So instead of having layer ones as different islands, where you have your chain, and if you want to get to another one, you have to either send funds to an exchange, or you have to rely on these various deployed bridges. Polkadot's idea was that we need to have a way to connect these different chains, and they have to be connected in a way that's secure. So Polkadot works as a blockchain of blockchains. So you can have your blockchain, deployed on Polkadot and running on Polkadot, and yeah, it's essentially like a layer 1 chain there, and Polkadot is wonderful because it abstracts away many of the difficulties of getting a proof of stake based blockchain going. So you don't have to worry about security because the Polkadot chain has its own validators. So what that means is that the blockchains that are running on top of it, they just have to collect transactions and organize them, and then all of the security comes from the Polkadot chain itself. So that's kind of a shared security model, if that makes sense. And with the Ethereum compatibility, I mean, the important part about that is that Solidity and the EVM has such huge developer adoption that when you want to make multi-chain deployments, right, you want to be able to make these quickly, and so Ethereum compatibility is is a must.
Yeah, let's go through the questions. Do you want me to read them out, or do you want to read them out for yourself and pick those that you want to address in any order?
Yeah, I'd love to. Yeah, I can see it. So the first one, we have email accounts. Okay, if you pick someone random, what's the quality of the validator? That's a great question. So I think this was regarding Bob's blockchain, and with Bob's blockchain, yeah, he had no way to guarantee the quality of the validator. In terms of proof of work, right? With proof of work, you have to invest so much in this specialized hardware that kind of the presumption is that you know what you're doing, right? And if you don't know what you're doing, then you're not going to earn rewards. So you will have spent all this money on this fancy hardware, and you're essentially going to be losing money because you're not making anything. So you'd have to be, participating in good faith. And in terms of proof of stake, the quality of the validator is kind of known by the stake that you're putting up. So if you are not producing blocks in an honest way, you could get slashed, right? That's the major outcome. But kind of the minor one is maybe you don't know what you're doing. You turned off your node at the wrong time. You forgot to update it, and in which case you would just not earn rewards for the time that you're like offline. Okay, next question. Is Sybil resistance the same thing as Byzantine fault tolerance? Not quite the same thing, but this is a great topic to bring up. I'm glad you asked this question. So Byzantine fault tolerance is the idea that you have some malicious nodes, and you need to have a way for the system to be resilient against these nodes. So in the Byzantine generals problem, you have like a couple of generals that are communicating, and you have you don't know if the generals can be trusted, and so you need to find a way where you can come to consensus and come to agreement, where one may be kind of submitting false or malicious malicious messages. And so the way that's handled in a proof of work system is that anyone who mines a block, they can submit, if they get the puzzle correct, they can submit the block that they believe to be true. And if they submit one that's false or fraudulent, the other miners will pick up on that. They'll see, hey, this is a fake one. And then they won't build their next block on top of that fake one. They'll go back to the last authentic block that happened before that. Okay, is proof of authority the most used model? No, but just to repeat, I don't think it's the most common one, but I think proof of authority is probably used by like companies and stuff like internal blockchain test networks and things like that. So proof of authority is probably like the least common one, but it's an important one to like just just look at. So how often do these attacks happen on proof of work? They happen actually a decent amount on smaller proof of work chains. So it would be prohibitively expensive. I don't want to say impossible, but pretty much impossible to attack Bitcoin because it's so large a network, and the amount of computers you'd need to attack the network, you can't just go out and buy these computers, right? You'd have to, it would be basically impossible. But for smaller ones, for smaller proof of work chains that have a fewer participants, right? That would be easier to attack. And so we do see from time to time attacks on these smaller and older proof of work chains. And when we say attack, right, somebody tries to take control of the network, and they would essentially try to do things like a double spend. And what I mean by a double spend is they might take funds and send it to an exchange, and that exchange might say, okay, we see you've sent us your money, and then they might try to revert that transaction essentially because they're in control of the blockchain. They might try to take those funds back. So essentially, that's a double spend. Next question is to do with Polkadot. So the integration chain question mark. So Polkadot can be thought of like a it's a layer 0 chain. So Polkadot's coordinating all these different blockchains that run on top of it. Polkadot's handling the security, they're handling the communication, and most importantly, kind of the coordination logic of who gets to run a blockchain on top of Polkadot, right? That's a big job, and they run that, and they do this in an efficient way. So through auctions and other mechanisms, so that we kind of make the most efficient use of resources on the Polkadot chain. Next question from Lisa. They contact with each other equals interoperability or through bridges, question mark. So on Polkadot, these layer 1 blockchains, they're connected to each other through Polkadot, through the relay chain. So it's not quite a bridge. It's much more secure than a bridge. And the reason for that is that all of the consensus and all of the final agreement that's coming through the Polkadot relay chain, and both these blockchains, they're running on the same Polkadot network. So there can never really be a huge disagreement in terms of what's going on, because the underlying model is the same. So when you're bridging from like other networks, let's say from Ethereum to Binance Smart Chain, those they're not connected in a native way, right? You're relying on these various wrapped assets and totally different protocols. And in Polkadot instead, you can think of it as like a native transfer. So a native transfer when you're transferring between different chains. Okay, cool. Next question I see from chat. A collator is a staking pool. Okay, awesome. Great question. So a collator is a block producer. So they're running a node. They're running a proof of stake based node, and they don't have to be. Let's see. No, they are pretty much a kind of like a staking pool. So the collator is just running their node, and they need to put up a certain bond, right, to be eligible to produce blocks and earn rewards. And then in order to select the top 64 collators, we select the top 64 by total backing stake. So total backing stake means in addition to their stake that they put up, how much does everybody else kind of pledge to them? And so, yeah, we can think of each collator kind of like a staking pool. So these delegators are putting their trust in this collator. Now the collator never has access to any of these funds. They can't take them or anything like that. You're just saying that, I know you're running a good node and you're earning rewards, and so I'd like to bond to you, and then I'm going to get a proportional share, proportionate to the amount that I put up. minus a small fee that goes to the collator. And the collator has to pay, for infrastructure costs and monitoring and things like that. It is, a semi-professional business, right? These are important infrastructure nodes. And so, they're not going to be running on their home computer. It's going to be in a data center. They're going to have a backup. But these proof of stake nodes are very efficient. They're not expending, lots of like useless energy like Bitcoin. Okay, can you tell us about any differences, if any, between Polkadot and Cosmos? Both are layer 0. Yes, so they are both layer 0s. I haven't done a ton of research into Cosmos, but I know that they're taking like a similar approach to Polkadot in terms of being like a layer 0 blockchain. So yeah, I don't have a ton of insight on Cosmos, but I need to, yeah, I would suggest like checking it out for sure. And oh yeah, what do the layers stand for? Okay. This is a great question. So we hear layer 1, we hear layer 2. Let's start with layer 1. So layer 1 is Ethereum, and for a long time, right, we can kind of all submit our transactions through Ethereum, and it was working really well until the network was becoming congested, fees are getting higher and higher, and it's becoming difficult to get your transaction through without paying $50 or something that's very, very high. So then layer 2s emerged as an important scaling solution, and a layer 2 varies in its forms, but you can think of it as kind of organizing batches of transactions and validating those transactions kind of in a much faster way, and then settling up on chain on the layer 1 in later at a later point. So there's many different ways that these like layer 2s are implemented, but the short answer is that they're a scaling solution in order to put through more transactions and take up kind of less space on the chain in general. So that's layer 2. But then layer 0 is kind of the newest term, and the layer 0 is like Polkadot in that it's providing the base layer infrastructure for launching other blockchains, and that's not to say that you can't also launch a layer 2 on a blockchain like Moonbeam. So we could have Polkadot as the layer 0, we could have Moonbeam as the layer 1, and then we could have layer 2 scaling solutions. And it doesn't have to be just a single layer 2. There could be many different layer 2 applications. And these are probably most useful for things where you need speed and high transaction throughput. So think games, right? Where you're going through a game and you're having lots of different interactions. This might be perfect for a layer 2. But if you're thinking of applications like, I need to make my mortgage payment, you're probably not going to do that on a layer 2. You're probably going to do that on a layer 1, and you might be okay with, the transaction costing a little bit more than a layer 2. Can you share more use cases of the needs to do cross-chain? Sure. So the idea with cross-chain is that you can have different applications that specialize, right? So one example is privacy. So Manta Network is a Polkadot blockchain that's working on a privacy solution. And this privacy solution can work with other chains, right? So you might want to do a swap to do like a private transaction. So you might want to transfer funds, or you might want to make a swap on a decentralized exchange, but you might want to do it in a private way. So that's just one example. But the idea of being cross-chain, right, is that the application that you're looking for, might be on a different chain, and you might want to, have access to that. And so, interoperability is a huge thing to be able to access these applications, on other chains. Is the stake model equal to everyone, or people with more amounts of tokens? Do they have more power in governance? Okay, whew. Yeah, this is a fantastic question. So in terms of high level, people who have more tokens would generally have more power in governance because they own more of the network in general. But proof of stake, I think, is a bit more accessible for people because, instead of buying these crazy computers, these crazy powerful, supercomputers, there's a way for people to get into the network and have ownership in the network and earn rewards with staking. And if they're not running like a node, they can also join like a pooled contract, which I think is a bit more democratic than the old like proof of work model. How do you compare to Avalanche's subnets? So yeah, those three chains that we discussed are kind of the ones that are doing layer zeros. So that's Polkadot, Cosmos, and Avalanche. In terms of how do we compare? So we would be a layer one, like Avalanche, and then for subnets would be like a layer two scaling solution. So we're exploring, layer two scaling, and these are options where we may be developing it ourselves, but we also may have like teams that are coming in and deploying their L2 solution. And so Ethereum has a lot of different layer two solutions, and so we may see like certain teams that have a lot of success deploying their layer two solutions on Ethereum, and they may want to deploy those on other chains, like layer one. Okay, so can you go through the details of the layer interaction? Meaning, how do the layers of the onion communicate? How does one layer use the other? Yeah, sure, certainly. Excuse me. So we have the layer zero. So that's the Polkadot, that's called the relay chain. And the relay chain, what that does is the relay chain is collecting, the relay chain is looking at every blockchain that's running on top of it. And it's looking at the latest block that each of those blockchains submits. And it's saying, is the block that was submitted by this blockchain, is that like a valid block? Comparing it to the last one that was submitted. So in essence, was the change in state, was that a valid change in state? And what it does is it takes that for all of its different blockchains that are running on top of that, and in a couple of blocks, it will hash that data, and it will essentially finalize those blocks. So it'll say, yep, everything here is valid. That is going to be an official, like a finalized block. Finalized meaning valid, and finalized meaning that it can't be reverted at a later point. And so how do these different blockchains communicate, right? So the Polkadot relay chain coordinates much of the communication, right? So these layer one blockchains, they're in constant communication with Polkadot. But we have a new technology called XCM, which stands for Cross Consensus Message, which is a way for these different Polkadot blockchains to talk to each other. And when we say talk to each other, that means that you'll be able to send value between different chains, but you'll also be able to make arbitrary calls. So meaning you could be on one blockchain and you could say, hey, I need to perform an action on another blockchain. And this chain could send a message to that other blockchain saying, hey, can you do this for me? And then it can get back a response. And so it sounds like a simple example, but it's extremely powerful because we don't know yet, all the features that would be built out on these different blockchains that are running on Polkadot. But we know that, if we can talk to them and if we can utilize their technology on different chains, then it can create like a much more seamless user experience, right? So that means that when you arrive in the Polkadot ecosystem, you you might be able to have the functionality of the entire ecosystem, but some of the details of interacting might be abstracted away. So it's a much more seamless experience for you. You're just interacting with the applications that you want to interact with. And last question from Elizabeth, is Chainlink also a layer 0? Good question. So I always thought of like Chainlink as like a layer 1. Chainlink, as you may know, is like in the business of providing like Oracle data, which is extremely, extremely important for every single, layer 1 and layer 2, and many different like applications that are running on these layer 1s and layer 2s. And Chainlink is the gold standard in terms of oracles. So the reason for oracles is that you need a way to get data that's like in the real world. So like weather data, price data, stock data, right? You need a way to get that into a blockchain. And because contracts and financial instruments, they rely on having reliable data, it's important that this data is like 100% accurate and cannot be messed with. So that's kind of the important thing there. All these questions have been wonderful. I appreciate all the engagement, and it's great to see all the curiosity and questions. So thank you.
It's super amazing, Kevin, how you broke down a seemingly very complex topic into less than 45 minutes in a way that it's easy to relate to. Maybe if you guys have noticed, it's even for people like Kevin, who's been in the space for a long time and also like building the space, you cannot be an expert in everything. So I guess the encouragement to all of you here on our mentoring session is just understand, enough that you kind of know where to look deeper, whom to talk to ask the right questions, and also know which part of the ecosystem we're talking about. Maybe just go back to week 2, we talked about the blockchain ecosystem, so you kind of get a more and more granular understanding of how these different players in the ecosystem, the validators, custodians, the exchanges, and so on, work together. And then you can dive deeper into one of these projects. Next week, we'll look into a few projects and seeing how do they actually operate as like a project inside the ecosystem. Now that we understand how the ecosystem works, how consensus mechanism works, how governance in theory works. And yeah, looking very much forward to seeing you again next week. Please fill the key takeaway surveys that you had. This will be important for your graduation. And Kevin, thank you so much for being part of the team and sharing your wisdom with everyone here in Unit Masters.
My pleasure. Thank you so much for having me.
Yeah, see you all again on Tuesday. Bye-bye.
Cheers.